Everybody to turn their phones on to mute as well before the next speaker. So our next speaker is Justin Clark, and Justin is an e-research analyst with QCIF, and his role is to procure research projects for development on Quern, as well as to develop relationships with researchers at the University of Queensland. And Justin originally came to QCIF from the Hurston Health Sciences Library, which is the largest health library in Queensland. And he was involved in supporting the information needs of the university staff and students from the University of Queensland's School of Medicine and School of Population Health, as well as supporting staff from the Royal Brisbane and Women's Hospital and the Royal Children's Hospital. And Justin today is going to talk to us about research services delivery in an integrated NeCTAR RDSI node. If you could welcome Justin.
Thanks, Tracy. Oh, excuse me. Sorry, that was very loud. I'm glad the test did work. So I'm Justin. I am second author, but Graham happily stepped aside and let me present because, you know, it's such an honour to be up here in front of everyone. For those of you who may not know, and hopefully most of you here do know who QCIF is, it's the Queensland Cyber Infrastructure Foundation, and we're owned and operated by 6 universities in Queensland. So that's our board of directors, and our job is to really try to help procure e-research services and high-performance computing services to, I guess, enable or better enable research in Queensland. So the paper is Research Services Delivery in a Combined NeCTAR RDSI Node. So early this year, I think around February, we decided to build what we called the prototype, or a prototype node, because we had put in bids and we were very, very hopeful of winning those bids to be a NeCTAR and an RDSI node in Queensland. Now, rather than jumping straight into it with no idea of what we were doing, we thought we would build a small test prototype first, so that if we were going to make some mistakes, and if researchers, and we would make those mistakes in a prototype environment as opposed to in a production level environment. So the main 2 purposes of Quern was to try to gauge whether or not researchers would accept and use a research cloud. We also wanted to identify and work out exactly what the challenges of implementation would be. So from a researcher perspective, so for gauging researcher acceptance, this is kind of the questions that we asked, and we were hoping that this node or this prototype node would answer. So would researchers happily transit from the desktop into the cloud? Would they accept the infrastructure as a service model, which is the NeCTAR RDSI model? And would the researchers actually trust the cloud to be secure and stable? From challenges of implementation, these are the questions that we were hoping to get answers for, and I am saying hoping to get answers for in some cases. If we built it, would they come? Which is quite a common theme going around at the moment. The other big one that was important to us was if we left them alone, would they actually use the stuff we gave them? Also, could we scale up? How much support would these guys need to actually transit and move into the cloud? And how best we could leverage the existing support infrastructures around the universities. And the final thing we were trying to do was work out how we could actually get the long tail into the research cloud. So this was the general specification. So I'm sure you've all seen the NeCTAR presentations and the scalability, and there's going to be millions and trillions of computer cores coming online soon. Our far smaller node simply ran at 400 computer cores with 500 terabytes of storage. So this was small enough for us to test and get interesting projects on without having to spend a fortune in case it didn't work. So we ran our Quern programs. What we did is we approached the universities and we approached researchers around the universities, and we tried to get projects up and running on our Quern node. To date, I believe we have 26 projects up and running at the moment from across universities across Queensland. So we've allocated 272 computer cores, and we've allocated 192 terabytes of storage so far to researchers in Queensland. We do have quite a large list of projects to come online, but we are hoping that the majority of those projects can move to the prototype node which I'm sure will be coming, but I won't be the one announcing when that will be coming. When we went out, we did want to ensure that the projects we got for Quern, in order to test it, we wanted to ensure it came from a very broad user base. We wanted to make sure we captured not just the big data guys, the big data researchers and the huge institutes that float around the universities. We also wanted to capture the small guys and the small data researchers out there. And even more importantly to us anyways was that we got researchers from all schools, both sciences and humanities, up and into the research cloud. So they were the main goals of our project selection and the criteria that we tried to run by. So this is just the research areas covered. So the bulk of these is actual research running on Quern. I think there are a couple in there which we haven't quite got up yet, but we have project plans for them that we're hoping to implement. So as you can see, it's quite a broad cross-section from around the research sector. So we go all the way from literature, epidemiology, neuroinformatics, and genome sequencing. So we did think we did quite well in the broadness of the research areas we managed to actually capture. So in order to actually select these projects, what we did at first was we went out into the research community and we tried to get people we knew or people we had relationships onto the node quickly. Because it was an experimental node, because we were building it, and we weren't 100% certain how it would all work, how it would all fit together, we wanted to make sure that the first people we got on would be very forgiving if things didn't quite work out the way they should. After we had a few projects up and running and we got a bit of a feel for how it would work, we then had to move up and interest came in. We moved our selection process to an allocation committee. The main purpose of this was communication, so everyone would kind of know and get a feel for what was going on. And also, we didn't want it just to be one or two people picking which projects get onto the research cloud. We did want a slightly broader group of people making that decision. So when we went out, our allocation committee had the following, I guess, set of guidelines to help them decide which projects made it, the cut, which were rejected. It was important that field of research was important, size of the request, and the type of research scenario that it covered. Preference was always given to requests that came from a school or a field of research that wasn't already on the node. So if you were, so for instance, genomics was on quite early. So if you were outside of genomics, or if you were from the humanities and we didn't have a humanities project up and running, we would have moved, given preference to trying to get the humanities project up. So today, this is just 4 projects that we have up and running that I would personally consider to be our most successful ones. So we do have the Genome Virtual Lab integrated into Quern at the moment. We're currently hosting longitudinal health data on Quern. We luckily managed to find some pretty clever guys who were willing to test it out and try to run Quern as a HPC-like environment. So they're using it to debug high-performance computing code before they send it off to the HPC. And we have got the UQ library on board, and they are using Quern at the moment to try to set up a project to obviously test the viability of checking and self-healing of Darker repository content. Exactly how the hell they're going to do that, I'm not too sure, but it does sound very exciting. So after we got ourselves a bunch of use cases on, and after we talked to researchers and started to promote it all, we started to build a list of very common research scenarios that we had either met or research scenarios that we were hoping to meet. So this is from talking to researchers. All of them had, well, most of them had reasonably common sort of needs that they wanted fulfilled. So they either wanted to host a web portal, collaborate over data, a bit of data storage, or they wanted to access the cloud through VLAR RT tools. So these are currently the fulfilled research scenarios that we've got. these are the other research scenarios that we are hoping to get sometime soon. So these are, I guess, the 7 most common things that researchers wanted from us. Of course, whether we can actually fulfill these 3, well, actually the top one, obviously we can, but the bottom 2, we're still working out how we can do that in the cloud. So after we got the researchers up and running on the cloud, gave them some time to work out the bugs, iron out any problems that might occur, we then went back and we did talk to quite a few of them. And so just from anecdotally discussing the cloud with researchers, these were the 4 main points that seemed to crop up time and time again. Obviously, timely access to compute power is important, access to resources from anywhere, increased ability to share and collaborate because they have full access themselves over who gets on and off their Quern virtual machine. The one that surprised me or was quite interesting to me was that quite a lot of them just liked the fact that they had additional compute power sitting behind their existing capabilities, which meant that they could take their work laptop, run a virtual machine, do some epidemiology or some statistical analysis in the background while still using their laptop to, I don't know, write papers or search Facebook. And then 2 or 3 hours later, they could come back and all of that processing would be over. And they could then take that data and start using it without having to waste time staring at their laptop, which was busy crunching code. So after quite a few months and a few headaches and a few problems and some successes, thankfully, these are some of the things we learned throughout the whole process. So we learned researchers actually understand what they want, and they do understand where they need to improve their research. And sometimes they understand infrastructure, sometimes they don't, but the honest truth is that they don't care too much about infrastructure. All they really want to do is solve their problems. Researchers working in the long tail of research have very little actual IT support, and so if you're going to engage with the long tail, you've got to expect that some IT support might be necessary. Providing VM and storage is not always helpful. Even the greatest researchers in the world cannot necessarily just make use of a raw virtual machine or raw storage. They may need some sort of tool or some sort of support to get up there. So our solution in this case was to make sure that someone went and actually talked to them, found out what they actually wanted, and tried to tailor some sort of solution that will meet their needs, as opposed to just saying, hey, here's a computer. This obviously wasn't always possible at the moment, but that is kind of the solution that we did come up with for the time being. So other lessons that we did learn is that communication is really, really important in this process at the moment. It's vitally important to manage researcher expectations because they all hear about the cloud, they see the IBM ads on TV, I guess, or the Microsoft ads, and they think that the cloud is going to come along and everything's going to be fixed for them. And it's not. They're still going to have to actually do some work. It's definitely not a silver bullet. IT supports around the university themselves need to be engaged with if you're going to properly engage with the researchers, because our feeling is that these guys are going to be the guys who are going to have to be the supporting network that underlies deployment of nodes and deployment of the cloud. Strong communication also is vitally important between all of the people involved in setting up, running the node, installing the hardware, and installing the software. So our greatest successes came after hardware people, software people, and the uptake marketing people at QSIF and the universities started talking together a lot better. So we've come up with a very short list of advice for operators. So these are things we've learned, and this is hopefully a bit of advice that might help other node operators get up and running, or at least get up and running a bit quicker. It's a very good idea to try to create some sort of service catalog. So don't ask them to select a bunch of computer cores and a bunch of storage. Ask them what their problem is and try to find a tailored solution to that problem. Now, this can obviously be a website, but using case studies or use cases to try to focus them in the right direction is going to be very important. And uptake strategy is important as well. They're not just going to, you build your node, you put the cloud up, they're not going to rush over and all sign up. You really do need to get out there and talk to them and explain to them what it's for and what it's not for. To manage, hopefully, the millions and millions of researchers around Australia who are going to use the research cloud, you're going to have to come up with some sort of service provisioning, self-management, self-service provisioning of this whole process. Now, that doesn't mean that in every case it has to be self-service. And I'm sure there will be scope for people to be helping and involved. But to manage, hopefully, the expectations of the research community, self-provisioning and self-support is going to be necessary. And make sure you enlist support from the IT people around the university sectors, because I think to make it successful, you're really going to need their help. And that's it. Thank you.
Do you have any questions for Justin?
Oh, great. Cool.
Hi, I'm Rebecca Parker from Swinburne. I'm curious, you mentioned that you've got longitudinal health data.
Yes.
Were researchers expressing specific concerns about that?
No, not at all, because they have full control over the machine. So they have full control over access, who gets it, who does not get it. So what we did in that case is that these guys approached us and said, hey, we have longitudinal health data. We're interested in testing the cloud environment to see if we can host it there and see if it will work. And so in this case, we just provided the basic core infrastructure they needed and said, look, here you go. It's now up to you to manage and sort it all out. And that was their preferred case anyway. So, yeah, if there is a problem, it is in this case their problem to look after it all.
Hello, Steve Bennett from Versity. 2 questions.
Yep.
First, what kind of promises do you make to your users in terms of long-term sort of viability of?
Well, we haven't made any. What we do is we're very, very careful to point out that the Quern, or the vQuern was and is a prototype model, and that they can't expect it to last forever, and it is really for test purposes and test cases. And as I say, managing that expectation at this point was vital, and there were a couple of hiccups along the way with user expectations around that. So we really had to be very careful in that regard. So we made sure that we told them, don't put anything mission critical on it. Don't expect that you can now switch your computers off or sack your IT guys.
Yep. And the second question is, what obligations do you place on them in terms of system administration in particular? Is it their obligation to, manage patches and, upgrade the operating system? And if there's a security flaw, for example, is that their fault or your fault?
Fortunately, so far we haven't discovered that one. We're very careful to explain to them that we will look after making sure the computers stay up and running, and we will provide them with an operating system. And after that, it's their responsibility. So, and we've also selected projects on that basis. So there were quite a lot of projects which maybe we could have taken on board, which we didn't because they couldn't, I guess, sort of manage and look after it themselves. So yeah, that was very important.
Brian Davis from the CSIRO. Just to follow up from the first question, one of the things we've found is in order to get the scientists to actually spend the time or commit the time to actually try something, they need to be able to get a return on it. And yep. I'm just wondering whether you, back to that sort of guarantee of service, whether you're saying, well, it's not, don't bank on it, but we will guarantee 3 months, 6 months, 9 months, whatever.
Well, I guess fortunately in this case, these were some research partners of mine who came and helped out, as it were. So they knew, like we were very upfront and we were very open and very honest with how the process is going, where everything is, and we said, look, you know, and so some of these guys were doing us a favour, as well as at the same time we're doing them a favour, and it was kind of that was how we tried to approach it, particularly initially. Yeah, because as I assume everyone knows when the funding runs out on these programs. So yeah, we really couldn't. Yeah, it was a very difficult sort of fine line to walk between getting people on and not over-promising. It was difficult at times.
Gareth Williams, CSIRO. I was interested in your comment on the communication and the communication between the teams making it work, and I was wondering whether that was actually causal or coincidence, and could you expand on what aspects of the communication?
God, I'd rather not. Yeah, it was causal. It was just a new environment, and we were experimenting and trying to do new things, I guess, and sometimes people worked a little bit in isolation, despite the fact everyone was working on the same project. I think there was a little bit of isolation sometimes, and other people weren't kept in the loop, maybe who should have been, and due to that, working in isolation. As you know, not always, everyone doesn't always work together well. But not that that was the problem in this case. There was just, I think, not quite enough information exchange. That's all I'm willing to say, put it that way. Oh, is it being recorded? Oh.
Michael James, also CSIRO. One of your slides talked about self-service portal as being an important facet.
Yes.
I can see a huge need for the ability for people to self-maintain once they're on track and going. You do not want them, an enforced dependence back on the support team of the thing. In the initial, and this is sort of from your experience going forward, what proportion of users would actually be capable of jumping onto a self-service portal, dialing up a system that made sense and proceeding, and what proportion need a receptionist in the foyer to listen to the request, filter, adjust?
Well, I guess all of the projects we have on can look after themselves. I would think the percentage is quite high of people who are going to possibly need some sort of system admin support. If you're going to engage.
Is this ongoing you're talking, or at the outset, just to get them
at the outset, well,
set off in the right direction?
All of them needed a bit of, not all of them, the majority of them needed a little bit of help to get up and running and a bit of information exchange to get them going. It wasn't a lot, maybe a few emails backwards and forwards between the provisioning team and the research IT guys. All of them, but we were using manual provisioning using KVM, so that was always going to be the case. We don't have OpenStack running on the Quern node yet. We will hopefully have OpenStack working on our production node when that gets deployed. But yeah, no, the NeCTAR guys, I guess, would be far better able to answer that question than us.
Rob Middleton, Centenary Institute. Do you see that you have any place in evangelism of better system management processes like Puppet or similar to ensure that if you need to more substantially change your infrastructure in the future, or you just need to be able to ensure everyone is sufficiently supported in the future, that it's not just ridiculously impossible to change later? Well,
I mean, our feeling, we're going to be, I guess, a node operator, and so we want to try to stay as far away from support as possible. So really, which I know isn't probably going to happen, but we'll have to wait and see. I really don't know at this point how it's all going to pan out in terms of support structures and how much help and
I think it's just a fear that many people have expressed over the conference, and nobody's willing to pick it up. I wonder at what level it will be.
Well, we're working very hard to make sure that support infrastructures that are currently in place around universities will hopefully take up a lot of that slack. Whether that is how it pans out, I don't know.
Are they present everywhere in your state? I know that they feel absent a little in some areas of New South Wales.
Yeah, also, it's been recorded, so I can't really. Some places are well supported, some less so. Yeah. Long tail particularly, I mean, look, if there's any private enterprise out there possibly offering to system admin for the long tail of science at, I don't know, $20 a pop or something, you might make a lot of money. I don't know.
If there are no further questions, I'd like to ask you all to join me in thanking all of our speakers for this session.